Every single day we're in and out of buildings, our homes, our offices, the mall, and we just trust that they're safe. But what's that trust really based on? Well, it's not just luck. There's a whole complex system working behind the scenes, totally invisible. So let's pull back that curtain and see what's really going on.
I mean, have you ever really stopped to think about it? What is it that guarantees the floor you're standing on won't just give way, or that the walls will hold up? And, most importantly, that if there's an emergency, you can get out safely. It's not magic. It's actually a single, massive rulebook that basically runs the show for any construction project.
And that's where our invisible guardian comes in, the Ontario Building Code. It's not just some guideline, it's a huge, incredibly detailed set of minimum standards for pretty much all construction in the province. We call it the OBC for short. It's the reason we can walk into a building and just assume it won't fall down on us or trap us in a fire. To really get how it works, let's break it down into its three main pillars of protection.
Okay, so first up, and this is a big one, fire safety. It's probably the most fundamental risk in any building, right? And the Ontario Building Code has a really smart, multi-layered plan to handle it. It all starts with the very stuff a building is made of. See, the code starts by basically dividing the entire world of building materials into two simple buckets, things that burn and things that don't. A material is called combustible if it fails a special fire test. So think of things like wood or some plastics. Then you have non-combustible materials, your concrete, your steel, your gypsum board. These guys are the building blocks of fire resistance, and the code is super specific about where and when you can use each type. And that brings us to the code's whole strategy for fire safety. It's a pretty simple three-step plan. First, limit the amount of flammable stuff you build with. Second, and this is so important, it compartmentalizes buildings. Just think of it like the watertight sections in a ship. The idea is to trap a fire in the room where it started for as long as possible. And third, make sure there's always a clear way out for everyone. Now, the main tool for that compartmentalization is something called fire separation. But this isn't just any old wall. Oh, no. It's an entire system. The studs, the insulation, the drywall, all engineered and tested to hold back a full-blown fire for a specific amount of time. Could be 45 minutes, could be 2 hours. And that time, that precious time, is what gives people a chance to escape and lets the firefighters get there. And this is where you really see the humanity behind all these technical rules. This quote, it's from the code's own appendix, and it lays out the thinking. It's not just about stopping flames. It's about making absolutely sure that smoke doesn't stop someone who might move a little slower or has a disability from getting to an exit. It's about protecting everyone. So the code protects us from what could happen, like a fire. But what about the most basic job a building has? To just stand up. That brings us to our second pillar, structural strength. The code has to make sure a building can handle all the forces pushing and pulling on it, all the time. But here's the thing. Not all buildings are created equal in the eyes of the code. They get classified based on how important they are. Your backyard shed, that's in a low importance category. A school is high. But a hospital, that's a post-disaster building. It has to be built to a way higher standard so that it's still standing and fully operational after a major earthquake or a flood, right when we need it the most. To get that strength right, engineers have to calculate different kinds of weights, or loads. First, there's the building's own weight. That's called the dead load. But then there's everything else: people, furniture, snow on the roof. All of that is the live load. And trust me, the code gets incredibly specific about what to plan for. For example, check this out. The code says that a dance floor has to be designed to support a minimum live load of 4.8 kilopascals. So what on earth does that mean? Well, it means that floor has to be strong enough to hold up about 100 pounds on every single square foot of space. Yeah, the people who write the code literally thought about a packed dance floor with everyone jumping around and put a number on it to make sure it's safe. Okay, so our third pillar is all about making sure that safety and usability are for everyone. I mean, a building isn't really working if a whole bunch of people can't use it, right? So the code's accessibility rules are designed to tear down those barriers for people with disabilities. And the core idea here is something called the barrier-free path of travel. Basically, it's a clear, accessible route through a building from the front door to all the important spots. And it's not just about putting in a ramp. The surfaces have to be stable and not slippery, the slopes can't be too steep, and there can't be any obstacles. It's all about creating independence for people, no matter their physical or sensory ability.
You've definitely seen universal washrooms before, but have you ever wondered why every single dimension seems so precise? Like the height of the sink, the exact placement of the grab bars, none of that is random. Every single one of those measurements is there for a very, very good reason. It all comes down to one word: independence. That clear space beside the toilet, it's required so a person can transfer from their wheelchair. Those grab bars, they're at an exact height and location to provide stable support. Even the door handle has to be a lever, not a round knob, so you can open it without needing a tight grip. Every little detail is designed for function. All right, so we've got our three pillars: fire safety, structural strength, and accessibility for all. But how do these rules from a giant book actually get enforced on a real, live construction site? Well, it all starts with the law. The Building Code Act, that's the legislation that gives the code its power, is crystal clear. You can't build or tear down a building without getting a permit first, period. That permit is the entry point. It's basically you saying, okay, I agree to play by the rules of the code. And this is where your local building inspectors come in. These are the on-the-ground guardians of the code. First, they review all the architectural and engineering plans to make sure the design is up to snuff before anyone even breaks ground. Then they show up to the site at key moments, like when the framing is done, to check that the actual work is being done right. And what happens if it's not? Well, the code has teeth. An inspector can slap a stop work order on a project, and that does exactly what it sounds like. All work on site grinds to a halt, right then and there, until the problem is fixed. It's a really powerful tool that makes sure our invisible guardian is always being listened to. You know, the Ontario Building Code is not set in stone. It's a living document. It gets updated every few years to keep up with new research, new materials, and new challenges. And that leaves us with a pretty interesting question, doesn't it? As our world changes, with more extreme weather events and incredible new technologies, what will the building codes of the future need to protect us from? What's the next big thing our invisible guardian will have to watch out for?